Hi, there is this video of artistic looking wires placed on a battery and then suddenly they start turning. Surely it must be the everyday Facebook bowl of sugar. I mean, how does it even run only from one side of the battery? Oh hey look, there is a single wire right here shorting the battery. Simple motor battery. There is a bunch of videos on such a simple motor. They usually stick a battery on a magnet, stick a wire on top of it, and bam, it starts turning. At first glance, it looks pretty fake, but at second glance and some analysis, it still looks pretty fake. I mean, with the magnet at the bottom, it's outside the loop at the top, but I guess the fields and the current runs from top to bottom. I think this is a job for the rectifier. That's a very underwhelming intro. Do it again. Rectifier. See, as usual, nobody explains it, so I have to use my genius. They must be blowing air on the wire to make it turn. Yes. But I have my doubts. Don't we need alternating current through the wires? Here I have a loop of wire connected to the live lines close to a magnet. So when I plug it in, it should turn or vibrate. Too much voltage. Let me reduce it by my auto transformer. Okay, let's increase the voltage. Wow, it vibrates. Simple enough circuit. Let's just make it with a battery and see what happens. So I have a strong neodymium magnet and I stick an AA battery on top of it. Then I bend some wires to make a shape like this. See, one side of the wire touches one side of the battery and the other side touches the magnet that touches the other side of the battery. So this will short the shit out of the battery, and depending on the type of battery, it could result in a couple of amps through the wire. This will create somewhat decent magnetic fields around the wires and kills your battery in a jiffy, or a few jiffies. Okay, let's see if it works. Nothing? It does want to move, but it stops. I can see the sparks and the wire is getting warm, so there is tons of current. How about one loop on one side only? Ooh. It does want to do something, but it stops. I made a quality loop. This one should turn. Come on. I was really hoping this would turn. Maybe the magnet is not strong enough. Let me add some more magnets. See, these magnets don't want to go together unless I rotate them and bam, they connect because they are polarized north and south on the sides. If I rotate it, they disconnect because the same poles fall on each other. I wonder if this is the problem. I have a set of tiny magnets that are polarized on the opposite surfaces. You can see this by the fact that if I rotate them, they don't disconnect. Okay, let's stick the battery on these. And stick them on a plier so they won't fall. And I have this piece of wire to go over it. Hey! It's turning! Oh, it fell off. I guess we can hammer a bit of dent on top of the battery. And this way it shouldn't fall. There we go! What happens if I put this one-sider on? Hey! It's turning too. This is great. This video is sponsored by Brilliant.org, where you can learn knowledge through interactive courses and exercise your brain by solving science, math, or computer problems. You can now gift the treasure of knowledge. Simply go to brilliant.org/ElectroBOOM and grab a gift subscription to help your loved ones finish their day a little smarter. Talk to your doctor if the knowledge doesn't last more than 4 hours in your brain. So it works. I knew it was real because I'm smart. Didn't you say they blow air on it to make it turn? Yeah. Who are you, Detective Pikachu? Get lost. Okay, now that we know it works in a specific magnet orientation, it should be easy to understand why. We have electric current, magnetic fields, and the force that turns the wire. So all we need is the right-hand rule. Here it is if you don't remember.
And you shall not be a dummy again! The middle finger is for refill. The thumb is reserved for the force.
The index finger is for current. You hold those fingers in this pose. If two fingers match their vectors,
You'll know where the third one goes!
let's assume this arrangement. The battery sends electric current from positive to negative through both wires. The magnetic field's direction is always from north to south outside the magnet and south to north inside. Using the right-hand rule, the magnetic field is that way, the current is this way, and so the force is pushing inside the board, or basically perpendicular to the plane of the winding. On this side, the magnetic field is backwards, and so the force is pushing outside the board. So the forces always pull the wires along with them and they turn. Same thing with a single wire on one side. But for example, if the magnet orientation is sideways, the fields going through both wires are pointing the same way. So for example, the forces are pushing outside the board on both wires. So it won't turn or it just jumps off the battery. Even with the single wire, initially it moves to the other side, but the forces flip and push it back and it settles somewhere in the middle. Everything makes sense now. Now to make it more stable, we can pull one magnet from the bottom, flip it around and put it on top of the battery, and then stick a metal washer on top of the magnet. This will help hold the wire even better, so you wouldn't have to hammer the battery. Not hammering the battery is generally a good thing. Now if we flip the whole thing around, the battery turns the other way instead of the wire. Great! It's quite easy to understand. There was another type I'd seen. Using magnet wire that's coated so that the windings won't short to each other, make a few loops of winding like this. Now loop the excess length of wire around the winding so it doesn't unwind, like this. Now this is important. Using a sandpaper, remove the coating on both sides of the winding on one side of the wire in this position. Then tape two safety pins to the end of the battery that will hold our winding. Now we stick our magnets on the battery that are also polarized with north and south on the surfaces. Now if we put the winding in there, it starts turning. How, you ask? Elementary. If the winding is in a position that the wires are touching the contacts and the current, for example, is running that way, then on top of the loop the current is going this way and on the bottom that way. But the magnetic fields would be going up and about around the same direction through both sides of the windings. Which means, using the right-hand rule, the force on the top side would push one way and on the bottom side the other way. But with these forces, if the loop keeps turning, they will end up pushing the loop back until it settles somewhere in the middle and it won't turn. And that's why we removed half of the coating from the wire, so it only connects to the contacts for half the turn. So the loop starts turning, but before the forces can slow it down, the winding disconnects from the battery and the forces disappear because of the coating on the wire. The loop continues turning because of its inertia until the wire connects again and the forces come back and it keeps turning like this. These are great concept motors, very good for demonstration and understanding the forces and fields. Did you know that this motor is very much the same as the first ever magnetic motor created by Michael Faraday? This is what made him famous and exposed his genius and led to electric motors that changed the world. Now maybe you can come up with a whole new and improved motor structure and change the world all over again. But first, you might want to improve your knowledge and critical thinking. So hop on to brilliant.org/electroboom and sign up for free, or get 20% off of your premium membership for full access. Now you can also gift the Brilliant premium membership to someone else, spark a lifelong love of learning, and knock off an item from your holiday to-do list. I have used brilliant.org myself, and it's filled with exciting interactive courses on math, science, and computer, and fun, easy or complex problems to solve, which is quite addictive to me. If you are also a fan of problem solving, not only you will be addicted, but also you will learn a ton from it, compared to, say, Sudoku that teaches you nothing. Nothing! Okay, maybe a way of solving a certain problem, but that's it.